HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman, hosted by Carl Franklin. This is Lawrence Ryan announcing show number 159, recorded live Wednesday, April 23rd, 2009. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. And by .NET Developers Journal, the world's leading .NET developer magazine. Online at www.sys-con.com. In this episode, Scott talks with IronPython programmer Michael Foord.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. Sitting down today with Michael Foord, a Python advocate and the author of the new book from Manning called IronPython in Action. And Michael works, actually paid for a living, to work on Python all day long for Resolver Systems. So I wanted to sit down with him and get an understanding about kind of Python, so what? I want to be convinced that this is an awesome thing. Thanks for sitting down with me, Michael.
No problem. It's great to speak to you.
So, where do you want to start? I mean, there's a lot of C# programmers and there's a lot of VB programmers, and now there are more choices. You know, for many years there was really just the two languages, and they would kind of play thumb war to decide which was on top. And then out of nowhere, the DLR and Ruby and Python, and then a whole litany of niche .NET languages that are dynamic based. Why did you pick Python? Why did you write your application in .NET at all?
Well, I come from a Python background. I've been developing with Python from about 2002. So I come from a background of dynamic languages, and living in the dynamic languages community, I've seen that the popularity of dynamic languages on the rise really ever since I started. Certainly when I started in 2002, dynamic languages in general and Python in particular really were a niche. And I think as computer hardware has been getting better, so raw performance has perhaps been less of an issue. But for whatever reason, dynamic languages have been becoming more popular. And then particularly with the explosion of Ruby a couple of years ago, interest in dynamic languages just rocketed. And I mean, we've seen at our International Python Conference, we've seen record attendances for the last couple of years. With Google App Engine and all the Google support for Python, there's been an enormous amount of interest in dynamic languages.
Now, for the average C# or VB developer who's listening, let's be a little pedantic and give me a definition of static versus dynamic in a way that someone who has never done anything in dynamic languages maybe could understand.
Well, they're slightly fuzzy terms, but I think that the clear difference is that in a statically typed language, the type of every variable that you use, the type of every object that you use has to be known at compile time. Now, in C# and VB.NET, that means you declare it. In languages like F# and Haskell, the type is inferred by the compiler, and it occasionally needs some hints. But whether it's inferred or it's declared, the type is known up front when you compile your code, so the compiler is going to pick up any type errors. In dynamic languages, the type isn't determined until runtime. Now, they're still strongly typed languages, so you can't do sort of crazy things like adding numbers to strings, which you can do in some languages. JavaScript and Perl, for example, will let you do that, and that leads to crazy bugs to find out. You'll still get errors, but you'll get runtime errors instead of compile time errors. And in dynamic languages, the semantics of what you do is much more determined by object behavior than it is just by specifically types. And that actually gives you a lot more flexibility in what you can do with the language. It's a lot less restrictive in terms of you don't have to fight against the type system as you're writing your code to do what you want to do.
Okay, so I'm going to ask some devil's advocate questions, kind of ignorant questions, to get an understanding about this. So when I see the dynamic language Hello World demo and one explains it to a static language person, they usually go, look, A equals a string, and then I go, look, A equals some other date. See how it just changed type dynamically? Isn't that amazing? That in itself kind of is says what you just said, but in a very, very, very simplistic way. So types can be changed at runtime. Types are inferred. How does that really change the the idioms that I use as a programmer? How does that make it more fun? I mean, it seems to me that when I sneak in and I'm a fly on the wall with a dynamic language programming group, they seem to be having more fun. Why is that two lines of code where I change a string variable into a date and nothing, it just happens? Why does that make it so much more fun to be a dynamic language programmer?
Okay, well, obviously that specific example is trivial and is actually generally bad practice, just changing the type of your variables on the fly. But, I mean, let me give you one specific example. I've had an email very recently from a guy called Mark Bloodworth, who's a Microsoft architecture evangelist, and he's been interested in dynamic languages for a while, and so he asked me, where do I think that dynamic languages fit best? Is there a niche that dynamic languages fit into? And now I think, first of all, there are niches that dynamic languages fit into, even for those who prefer statically typed languages like C# and VB.NET, and hopefully we'll get to some of those use cases, even if you're not about to jump ship. But one of the things, as I've been using C# more and more, we've got a bit of C# in our code base. I wrote a lot of C# examples for the book, embedding C# and so on. And I'm becoming more and more convinced that dynamic languages actually allow for simpler architectures. And that's partly to do with the dynamic typing itself, and it's partly to do with less inherent complexity in the runtimes that they assume. But just to give one specific example, a colleague and I did a tutorial, an introduction to IronPython at the recent Python conference. And one of the things we did was write a database application that worked with various different databases. Now, if you've done that in .NET and you've used the different sort of database provider classes, then some of the connections you're creating for all of the different databases, they don't share a common interface, and they're all different types. So if you want to be agnostic about which one you want to use, you've got to write this extra layer over the top, which will say, right, if I'm using this particular database, I'm using this particular class, and I need to put an interface layer on top of it so that I can have easy access to it without having to compare without having to care in the next level up of the code as to which one it is. Whereas in Python, we just had a very simple bit of code that says, right, depending on which one I'm using, I'll import the correct class, and I'll import it, and I'll give it a common name, SQL connection, whichever one of those it is I'm using. And then I just need to store a little bit of information about which of the parameter classes I need to be using, and so on. So there's this whole layer of architecture we could remove just by being able to dynamically do the lookup for which class we needed to use at runtime, rather than having it sort of statically baked into our code.
Now, is that something that's fundamental and really only possible in a dynamic language, or is that something I could have, if I'd known the pattern, I could have done in C# using some clever bit of reflection? Or
well, you can always do it in reflection, but I think reflection is one of the wonderful examples of the differences between dynamic languages and statically typed languages. Because if you look at reflection in .NET and the kind of code you have to write, it's kind of ugly because you're carrying around these system.types, and you have to call. If you've done any of it, you just know it's a bit painful. Whereas if you look at the introspection capabilities of languages like Python, Ruby, and Smalltalk, it's all beautifully simple, and you can just look up members, you can call members, and because you're late bound, because you're dynamically typed, it's all so straightforward.
Okay, so a lot of people have been taking IronPython as a dynamic language that also does .NET and been embedding it. It seems to become the scripting language du jour, where you have an app and you want to make it scriptable. You drop in IronPython.
Right, and I think that's one of the main use cases for .NET developers who aren't about to jump ship and write their applications in IronPython. But if you want to add scripting capability, if you want maybe an extensible architecture, you've got a ready-made scripting engine. And it was designed for this from the start. So the API for embedding, for calling code, for creating instances of classes that are written in IronPython is all very simple, and it's going to get a lot nicer in C#4 as well.
Okay. Now, how do you use it as a scripting language in your application? And how did that come about? Because you said there was a little bit of a history there about what happened first.
Well, the application that we've created, Resolver One, it's a programmable spreadsheet, and the idea is that because spreadsheets get used to create business applications, and they rapidly grow out of control and become very difficult to maintain. I think anyone who's been involved in business has sort of seen that happen. The idea was, by the guys who founded the company, was to create a spreadsheet system that was programmable right from the start, and that was baked right into the heart of the application. And so the idea was that it would have this interpreted language embedded in it. The formulae and the data that you put into the spreadsheet would be turned into, in real time, code in this interpreted language, and then mixing in your own code and interfacing to external systems would then be very easy. And because it was a desktop application and it was going to be aimed at businesses, they chose .NET and Windows Forms as the platform because they're very established technologies. And they kind of assumed that they were going to be writing it in C# because that's, if you're writing a desktop .NET application, that's just what you do. You write it in C#.
Yeah, or VB. I mean, I guess really you sit down and you say, I guess these are the two choices I have.
Yeah, and you pick whichever one. I mean, one of them was an ex-Java developer. One of them had done a lot of C++ and Objective-C. So C# seemed the more natural fit for what they were going to do. But they needed to have this interpreted language embedded in it, and IronPython was about version 0.7 at the time. And this was a few months before I joined the company. And they started playing with IronPython, and they found that, first of all, everything they wanted to do with the .NET framework, they could do from IronPython. The integration was very good and very straightforward. So you can import the classes, you can add references to the assemblies, you can use the classes. All the features of .NET are available to you. But the second thing was that Python was very easy to learn, and so not having used it, they found that they were picking it up very rapidly. They really enjoyed it. They liked it as a language. But the other thing was that they decided to use test-driven development. One of the guys who founded the company has used test-driven development before and is a real fan of it for producing quality code and for creating a system that's maintainable. And one of the big things about dynamic languages, because you can override behavior at runtime, they're dramatically easier to test. And so they had this crazy idea. They thought, well, let's prototype the application in IronPython. We'll see how far we get. And then at some point, presumably, we're going to hit a wall, whether that wall is performance or stuff we can't do. But by then, we'll have a great prototype, and maybe we can keep the testing stuff in IronPython. Who knows? And that was over 3 years ago. We've got sort of I think it's about 40,000 lines of code in IronPython now, a few hundred lines of C#, and about 150,000 lines of IronPython code in our test framework. So really the choice to use IronPython was made, or the choice to use Python was made after the choice to use .NET. It kind of happened by accident. And when I joined the firm, I was the first one with any experience of Python, which was quite fun.
Now, did they ever acknowledge that they're not turning back?
Oh, yes, yeah. I mean, now it just wouldn't make sense, except for the fact that we've always said that for performance reasons, if we can get better performance by recoding parts of our application in C#, then we'll do it. We're not we're not doctrinal about it. We need to do what we need to do, but we've actually looked at performance at various times, various bits of the application, and doubtless we'll have to do it again in the future. We're probably about due a round of that, actually. And every time we've come to look at performance, we've said this particular operation or these set of operations needs to take X amount of time, and it's currently taking Y. That's too long. And we've always got the performance we needed by refactoring, by profiling and optimizing our Python code, rather than having to drop down to C#. But the nice thing about IronPython is that the integration is so good that if we were writing classes in C#, we would just be using them as native Python classes. So other than having to do a bit of coding in C#, it wouldn't require us to change much in the application to do that. And I think this is one of the things about dynamic languages. People have this impression that they're slow, they're not suitable for large-scale applications. Right. And I think that largely, basically entirely comes from people who haven't actually tried them. If you're ruling out a dynamic language on the basis of performance, then you're making a premature optimization. And largely, programs run slow, not because the languages are slow, but because it's hard to write code fast, and it takes work.
Now, one thing that you said there was integration, and I think when people think about integration, there's two aspects of it. There's, like you said, talking to the BCL and being able to, to speak to the base class library and to integrate with other .NET languages in a fairly seamless way. That's one kind of integration.
There is a gap. The moment the gap is with attributes, .NET attributes, which can be a problem for some libraries. So we have written stub classes in C# where we've needed to access attributes. And the main reason they haven't integrated that is actually because there are various reasons, but one of the reasons is that it's hard to find a good syntax for it in Python. So we're bugging the IronPython guys, and we'll get that soon, we're assured. But yeah, that's one side of integration. Okay,
and then the other aspect is integration with the with Visual Studio.
Right.
There's this sense that if you can't go file new whatever and get syntax highlighting and some kind of IntelliSense and debugging, then it's scary, or it's scary enough, or it's off the main beaten path enough that a company will say, I don't know what kind of toy language this is, but I'm not we as a company, whoever we are not going to standardize on this because it's not in Visual Studio. It's not real, right? It's not actual until the little .py files, you can double click on them and start typing and you get IntelliSense. What's the experience as far as integration in IronPython?
Well, unfortunately, the integration with Visual Studio 2005 is better than the integration with Visual Studio 2008.
Really?
With Visual Studio 2005, you get this. You have to install the SDK, which means you need Visual Studio Professional. But the SDK has got pretty good integration in terms of debugging, in terms of the designers, and you get the syntax highlighting, of course, and some IntelliSense. IntelliSense is something that's hard for dynamic languages because the types aren't known until runtime. So Visual Studio really does the very minimum. There are actually much better Python IDEs, which are by people who've been working with dynamic languages for a lot longer, that do a lot more work on statically analyzing the code, inferring the types, and giving you good IntelliSense, good autocomplete. So my preferred IDE for Python is an IDE called Wing. But in Visual Studio 2005, you do get that. Now, in 2008, there's this external project called IronPython Studio, and that uses the extensibility shell.
Right, they call it VSX, right?
Yeah, that's right, yeah. And you can run it on its own as an IDE, or you can run it integrated into Visual Studio. You do get syntax highlighting. You get the same limited IntelliSense, so that works. The basic stuff works, but it was really done as an example of Visual Studio extensibility, and so I found that the designers crash, for example, and so on. So it's not something that I really recommend using to people.
So it sounds like it's not quite a slam dunk. It's not quite to the point where I can rush over to my boss's office with a laptop and say, well, we got to do it in IronPython. Look how awesome it is. See how it integrates with everything?
That's right, and we'll see what they come up with in Visual Studio 2010. I've only just finished the book. It came out in Amazon.com literally a couple of weeks ago, so I haven't looked at what they've done in Visual Studio 2010 yet, but I'll be having a look at that. But I was at a conference with Martin Fowler very recently, he's of course a dynamic language enthusiast who works for ThoughtWorks. And he really became turned on to dynamic languages through Ruby, and over the last few years he's seen ThoughtWorks do more and more Ruby projects. It's still only, I can't remember exactly what he said, about 30% of their work or so on is Ruby. They still do a lot of Java, they still do a lot of .NET. But one of the things he said is that the folk who switch from Java to Ruby, they typically switch from using Eclipse to using editors like TextMate, Vim, Emacs, the much more lightweight editors. I always say lightweight tools for lightweight languages. And he said the interesting thing is the refactoring support that you have in Eclipse. He hasn't heard anyone complain about missing it. Now, these tools are available for dynamic languages. There's some very good tools for Python out there. I think it's a bit of a myth that tools don't exist for dynamic languages. I think exactly what you were saying earlier, that when people say the tool support isn't very good for dynamic languages, what they mean is it doesn't run in Visual Studio. But the interesting thing is that the developers who do switch actually tend to end up using much more lightweight editors anyway.
Hi, it's Scott here from Another Place and Time. I hope you're enjoying the show so far. I apologize for interrupting it, but I wanted to let you know that assembling a podcast like this every week isn't free. Certainly the bandwidth bill crushes us every month, so I want to let you know that this show is sponsored by Telerik. They make the show possible, and they make some pretty cool products as well. For example, if you're trying to build a Web 2.0 AJAX-E application, trying to use the Web 1.0 components, it's kind of difficult. You got to get the next-gen stuff if you want to build the next-gen websites, and that's exactly what the folks at Telerik have got in their new upcoming product, which is codenamed Rad Controls Prometheus. It's a big pack of web controls built entirely on top of the Microsoft ASP.NET AJAX stuff that you already understand. It's going to give you a lot of performance and interactivity on your next project. They mirror the ASP.NET AJAX API, so the development's really straightforward. Client scripts are shared, loading time is pretty fast. You set a couple of properties, you can even bind to web services for a really efficient operation. The new RAD editor for ASP.NET AJAX loads up to 4 times faster than before, and the RAD grid will do thousands of records in milliseconds. But of course, it's better to try these things for yourself, so you can visit telerik.com/ASP.NET AJAX and download a trial. Thanks a lot for listening, and we'll get right back to the show. Now, did any of this integration or lack of integration become a problem with your company? Did you have to keep kind of convincing them that no, don't worry, this is supported, this is real?
No, and the interesting thing is whenever we've hired, we've never made knowing Python a priority, because we know that if we hire good developers, that they're going to pick up Python very quickly. And as I said, I prefer the Wing IDE. It turns out that most of the rest of the developers in my company, there's this war between the Emacs users and the VI users, and we do pair programming. So whoever you pair with, you end up using their IDE. So if you're a fan of Vim, you end up using Emacs, or the other way around. There's a bit of pain there, but that's just never been an issue for us.
Now, you've been doing this for a very, very long time, but what is a good way for someone to sit down and learn a dynamic language? I mean, should a .NET programmer, a VB, or a C# programmer sit down and try to learn IronPython, or should they go and get straight Python and kind of learn the other side and then try to bring it over to bring their knowledge over to IronPython once they've got the basics under?
The great thing about IronPython is that really you're just using the .NET framework. I mean, I often look stuff up on MSDN, and I need to convert the C# examples to IronPython, and very often it's just a case of remove the type declarations, remove the new, remove the curly braces, remove the semicolons, and bang, it's valid Python. And
really?
the syntax really is very clear. It is a very easy language to learn. So, and if you're starting with IronPython, having done C#, having done VB.NET, you're going to find most of what you're doing very familiar. So it's actually a very good way to learn Python. Obviously, I recommend as the very best way of learning IronPython in Action. It's a fantastic book, but Python is really very easy to learn.
Now, your book, the IronPython in Action book that you wrote, is that something that is appropriate for someone to just get started with?
Yes, I wrote it specifically with that in mind. The second chapter is a very fast-paced Python tutorial, and then it goes through, there's a few chapters of just writing a simple structured application in Python using various of the language features and using various of the features of the .NET framework. But there's hopefully enough in there that it should serve as a reference as well, and there's chapters on Silverlight, on WPF, on system administration. One of the things I love with Python, though, is that the very first chapter introduces the interactive interpreter. And the interactive interpreter, you can fire it up, you've got a console, and you can start to execute code immediately. So you can import your classes, you can start to create instances of them. So you get to play around with things in a very interactive and a very exploratory sort of environment. And I know .NET developers who they don't really use IronPython in production, but they do use the interactive interpreter as a tool for exploring things that are new to them and just trying things out. So the interactive experience is one of the things that's very important with dynamic languages.
Have you used PowerShell at all?
I've used it a little bit, actually mainly through writing the book, because one of the interesting things about PowerShell is you can embed it into other languages, and the same thing with IronPython. So in the chapter on system administration, there's a section on embedding PowerShell in IronPython and a section on embedding IronPython in PowerShell. And PowerShell, for example, the WMI integration and the COM integration is very good. So you might want to take advantage of that from IronPython. And then IronPython you can use to overcome some of the things that are harder to do in PowerShell. So yeah, I've played with it a bit. I haven't used it a great deal.
Well, I bring it up because a while back I had an application that I wanted to make scriptable. I had a fairly organized object model, and the way that you made that scriptable in PowerShell was that you just fired up an instance of one of these PowerShell engine objects or whatever. I don't remember, PowerShell host or something like that. You fired up a PowerShell host, you handed it your object, your live running instance of an object, and then you said .run, and that was kind of 3 lines, and instantly you've got scripting. Now, fast forward many years, and now I've got this Baby Smash game, which I want to turn into an educational tool. I've got a bunch of objects, and I want to make it scriptable, because rather than me adding functionality to it, why not let the parents just write Python?
Right, great.
Walk me through what's involved in taking some application, doesn't matter what it is, it's just some basic application that has an object model, and making it scriptable.
Well, it's very similar to doing it with PowerShell, actually. At one conference, I had Mark, the PowerShell guy, who's got a very good blog on PowerShell, and he showed me one of his examples with a turtle that you could write little scripts and move the turtle around the screen like logo, and I converted that over to IronPython, and it was like one extra line of code, I think, to change his example to scripting with IronPython. So it's quite a similar experience. You create the Python engine, and then you create a context that you're going to execute your code in. That's like a namespace. So where variables are created by the script or objects are instantiated, the context is where they're going to live. And then you just execute code inside that context. So if you want, so the big question is always, well, how do I expose the object model from my application?
Exactly. And my question, before you continue, my question is, what should my object model look like?
Well, an execution context is really just a mapping. It's just effectively a dictionary that maps names, strings to objects, which then appear as variables in the user's context. So you could put classes in there and let the user instantiate them. I mean, Python has its whole execution model is based around modules, which are a bit like namespaces in C# and VB.NET. So you can make things available to import by effectively making them as available as modules to the embedded engine. So you can either put them directly, you can just put objects directly into the namespace and say, right interact with this, which is how the turtle was. You had a turtle object that you could call move forward, turn left, and this kind of thing. Or you can you can expose the object model as a series of modules that the user can then import. And you can then have hooks which say, right, if they create instances of these classes, I'm going to collect them. So when their script is executed, I can then introspect the instances that they've created, pull those out, and then maybe each instance is going to be an instance of a command object. There's an example of that in the chapter 15 of IronPython in Action, which is writing a .NET application with plugins, and the plugins are written in Python code.
Oh, very cool. Okay, cool. So chapter 15 of your book.
I'll make sure you get a copy, Scott.
Oh, well, I guess the membership has its privileges. Thank you. Okay, so now do when you're hosting IronPython in your application, you're still in the CLR. You're hosting the DLR runtime. But as far as keeping track of what am I trying to say? Keeping track of conflicts and things. I mean, this is just another library. It's not like a new app domain fires up, right?
No, that's right. Yes, it's executing in your app domain. There is built-in support to say in the dynamic language runtime to say, right, create me a Python engine and create it in this app domain. So keep it completely separate, and that's quite useful if you want to add plugins and user scripting, but you want to restrict the privileges of what the user can do. But you may not want to do that.
Now, from a security perspective, though, what kind of things do I want to think about? I'm going to be suddenly opening up a huge chunk of my application for, really arbitrary code execution. I'm saying, here, take this text box and put whatever you want in it. How do I keep someone in Resolver or in Baby Smash Python edition from writing format C:? Right.
So the thing to do then would be to put the Python engine inside its own app domain and set the security privileges on that. And then when you want to look at objects from your side of the barrier, they're going to be serialized across the boundary for you. But the code, the IronPython code, is restricted to only doing what you've allowed it to do.
Do you guys do that with Resolver? How can someone avoid attacking Resolver in that way, or is that not really an attack?
Well, we don't see it at the moment as an attack, because the code you're running on it is the code you've written, so it's intended as an application development platform. So we don't want to very heavily restrict what you're capable of doing, because the whole point is you're supposed to be capable of doing whatever you want. But that's certainly something we're looking at for the future for having a restricted execution model.
I guess it becomes more of a problem when one introduces something like an online gallery, or they give their plugins their own extension and make it such that someone could download plugins quickly.
Yeah.
If Resolver had a large community of shared scripts, then things and it's one click to import it into your application, then I suppose that might be more dangerous.
And we would like to see that happen. So it's definitely something we've got an eye on for the future.
But it's good that sounds like IronPython supports that very nicely with the having other app domains and then being able to have different trust for those app domains.
Right, yeah.
So what do you want to change about IronPython? I assume you talk to the team all the time. Where does it completely fall down? Is it just the attributes thing that you mentioned earlier?
Well, that's quite a big hole. It will get filled. I guess the one thing at the moment, if you're working from the embedding side, and you're embedding IronPython into C#. The difficulty is when you're working with objects on the C# side, you need to know the type up front. So you've got a compile time. So you've got this kind of impedance mismatch between I'm creating objects at runtime by executing user code in a dynamically typed language. So those objects don't even exist until runtime. But then I need to interact with them from the statically typed side, where I need to be able to say at compile time what type those objects are going to be. And of course, if you're executing arbitrary code, you just don't know what's going to happen. And certainly if you create pure Python objects, then the object you get is of a dynamic type, and so you can't say to the compiler at compile time, give me this member, or I want to call this method, because the compiler just doesn't know where to look. That method doesn't exist until runtime. So at the moment, the way around that is the DLR itself has got its own API that says, right, give me a dynamic object and tell me what method you want to call, and I'll call it for you. And it looks a bit like reflection. It's not quite as intricate as reflection, but it just the code for then interacting with dynamic objects starts to become a bit more verbose than you'd really like. One of the very interesting things is I think the fix for that they've got coming in C#4 is really very elegant. And what you can do is you can say, when I've got objects that I've created from IronPython and I want to pull those and interact with those from C# or VB.NET, what you can do is declare their type as being dynamic and say to the compiler, this is a dynamic object, so don't statically compile my member lookups, my indexing, when I use this as a numeric object, all of these things that would normally be resolved at compile time. You say, this is a dynamic object, you need to do it late bound when the code is actually running, and it calls back into the DLR, and it does all this stuff for you. So that's something that in C# is going to be a lot nicer. But I don't know how quickly a resolver we're going to be able to depend on C# for our application. We'll have to see how quick the take-up is on that.
Now, one of the things you just brought up, I thought we should probably talk about just before we finish up here, was the notion of the dynamic object. I think that C# and VB developers are familiar with the concept of system.object. But you just kind of in passing mentioned that an object that I created in Python, if I go and created a person object and gave it some behavior, and it found its way over into C# or VB, it's not quite going to look like I might expect if I started exploring that object. Can you talk a little bit more about that?
Sure, and one of the difficulties is that Python classes are a lot more flexible than C# classes. You can add members at runtime. You can override members at runtime. Classes can be garbage collectors. You can create new ones at runtime. And in fact, none of the classes are even created until runtime. So if you create a Python class, that is not a true C# class. You can't statically reference that and then use it directly. But these features are one of the things that make testing dynamic languages so much easier, because if I want to test that calling method A calls method B passing in certain types, we can override method B at runtime very straightforwardly. Things like dependency injection and inversion of control they're good architectural patterns anyway, but they're often used just so that you can make your code testable, and they're just not needed for those reasons. But the downside of that is that if we want to use these classes from C# or VB.NET, we haven't got a .NET class to use.
Okay, so let's dig a little bit more into that, because you've mentioned a couple of times that it makes testing really easy. This is because of mocking, right? We don't mock the same way in a dynamic language that we do in a static language?
Yeah, for example, suppose you have method A and it takes two parameters, X and Y. Both of those you have to declare the type, and that calls up to method A. There are mocking libraries that you can use in .NET to achieve all that, but particularly in Python, the runtime isn't going to check the types of X and Y. What it's going to do is check the behavior. So long as you pass in some object that implements the same behavior, it doesn't matter if the types don't match. And the same with, we've got method A calling up to method B. We can actually override method B to check whether it's been called. And that's very simple, very, very little code. And we can even do things like, suppose method B instantiates a class.
Right. That would be a dependency. I would solve that with dependency injection.
Right, you would change the architecture of your application in order to make it testable. Whereas in Python, we can override that dependency at runtime and say, for the purposes of the test, just during the execution of this test, that class name, when it's looked up at runtime, I'm actually going to give you my object and test that you've instantiated my object. Now, if dependency injection turns out to be a better way to write the code, then of course you can still do that. But you don't need to change the way you write your application just to even make it testable.
I see. Okay. Yeah, that's interesting. You just said that you wouldn't have to change the way that you write your application just to make it testable. And that's kind of one of the little bit of points of tension in doing development. Test-driven development kind of makes your stuff testable by virtue of the fact that the tests are driving the way things are going. Yeah, so
you're forced to write it in a testable way. And we use test-driven development, and I think it's I'm a big advocate of it. I didn't do it before joining Resolver, and it has changed the way I develop. I think it's a fantastic way of thinking through and designing your APIs. But it doesn't quite change the style of your coding quite so much necessarily in a dynamic language, because you don't have to jump through hoops just to do the testing.
Huh, okay. And then you think that's a big win for dynamic languages in general, if I'm trying to convince someone to start looking at dynamic languages?
Testing really is orders of magnitude easier. You've got no compile time, which is one of the first things. So you've got this very quick, rapid feedback of edit, run. So it's particularly when you're doing TDD, where you write a test, run it, watch it fail, write a bit of code, run it, see whether the test now passes. That feedback cycle is very rapid with dynamic languages. You cut out the compile phase, but also the features of the language really make themselves amenable to testing. And again, there's a very good chapter on that in IronPython in Action, which goes through things like the way you use mock objects with dynamic languages, things like monkey patching, modifying live objects, which is something that in general is bad practice, but for testing it's very it's quite ordinary and very useful. And it also talks about dependency injection and how we do that. But again, with dependency injection, we don't have the type problem. We can swap in objects of any type. Now,
you just said monkey patching. For you, that's a throwaway word, but for people who are listening, that's probably not a throwaway.
Right. Monkey patching it's a term that actually originates in the Python community. The Zope, which is the big granddaddy of Python web frameworks, and all the Zope developers, it originated as an object publishing framework, and The big application written on top of it is called Plone, which is a content management system very widely used in Europe, and it's been around for years. So they're sort of quite annoyed with these upstarts, the Django and Rails and ASP.NET MVC, which are just discovering all these things that they say they've been doing for years. But it's a very big and heavy framework, so it's got a bit of a funny reputation in the Python world. But they came up with this term for modifying live objects on the fly, and they called it guerrilla patching, with the GUE, with the sort of thing, doing things sneakily on the fly, and that's kind of, that term morphed through guerrilla patching to monkey patching. And it's a term that's got a bit of a bad reputation in Python. You can modify live objects. You can change the implementation at runtime. But if you do that in production code, what you end up with is behavior that when you then go back to the source code to look at where that behavior is implemented, you're reading the code and you're thinking the code I'm looking at is being executed, but some other part of your code has actually modified it at runtime, and something else is actually executing. So it's something that within the culture of Python just isn't done a lot. But then Ruby came along, and you can modify the built-in types, the very sort of primitive types in Ruby, which is something you can't do in Python. You can attach new methods to integers and strings, and they took up this term monkey patching, and it became quite a common term within the Ruby community. So it's a term that's quite well known within the dynamic languages community.
Does that mean that when .NET developers use extension methods, we are monkey patching, and that's bad?
Well, kind of. It's statically resolved. So, for example, the very common problem that can happen, it's not that common, but it certainly has caused real problem for real developers in Ruby, is that where you have two libraries that define the same methods and patch the same methods onto integer or onto string, but have a different implementation and perhaps even take different number of arguments, they're going to clash, or things aren't going to be called in the way you expect, and you're not necessarily going to know about it. I mean, obviously, if you're testing, you'll probably find out about it earlier. Whereas I guess if you're using C# or VB.NET, it just wouldn't compile.
I see. So in that instance, it is monkey patching kind of technically, but the fact that we have that initial unit test.
Well, it is, and I guess you could run into the same situation where you get convenience libraries or even parts of your application that try to define these common methods and think, well, instead of providing these as static methods or functions, as we'd say in a world where you have real functions, we're going to be clever and patch these on as extension methods, and then suddenly you've got conflicts, and you've got code trying to call things that actually don't exist, and you've got to try and sort that out yourself, which I guess is one of the common arguments against overuse of extension methods.
Okay, well, I've got one last question, which is kind of like a more of a comment / question. But someone told me once that when arguing about static languages versus dynamic languages, that compilation was really just a unit test, and that dynamic languages could compete with static languages if the argument was simply that, oh, well, I have this compiler and it makes things safer, if you have a unit test.
There's this great quote by this guy, I think he's called Stuart Halloway, and he said that in years to come, we're going to see compilation as the very weakest form of unit testing. And the thing is that compiling really does catch only a very small subset of all possible bugs. And, I know some programmers think that if their program compiles, it doesn't have any bugs, but I suspect that they haven't been programming for very long. And really the kind of bugs, the type errors that it catches, are really the sort of ones that are quite easy to catch and the minimal amount of testing. If your code is making the wrong assumptions about types, then really just exercising that code in almost any way is probably going to pick up those bugs. And there are also automated tools. We use PyLint, which is a coding quality checker that runs over our code base and catches a lot of the kind of errors that compilation would normally catch.
Compilation really just catches nothing at all, if you think about it, when it comes to how it doesn't tell you anything about how you expect your application will run. It's like saying, well, I've written a fine novel here and everything, it's a wonderful novel, the spell checker said so.
That's right, yeah. Exactly, and I think if you care about the quality of your code, you're going to have automated tests. You're going to test that it behaves how you expect it, and in which case, really, compilation has bought you very little. And it turns out that in maintaining this type safety and adhering to this type system, that there's actually quite a cost in what it allows you to do, or more important, what it prevents you from doing.
Well, Michael Foord, thank you so much for sitting with me and talking about Python today. And folks, remember that Michael's got a book out called IronPython in Action, and your name online is Void Space, right?
voidspace.org.uk/blog will get you to my blog, and there's ironpythoninaction.com, book's website, and don't forget resolversystems.com for Resolver 1, which everyone should try out. It's a great program.
Fantastic. Well, this has been another episode of Hansel Minutes, and we'll see you again next week.